introduction. So today I'm also a mathematical physiologist, but today I'm going to pretend as if I'm an epidemiologist, okay? So there might be some terms which I may not be able to define correctly, okay? So but just take it the way it is. So this work was done with MPI guys, those in the surveillance team at MPI, and the last person here is Emily Valley at School of Veterinary Science at Mercy University. Okay, so today I'm going to talk about this particular disease, which is a poultry disease. As we all know that in the last week there was a case of avian influenza in New Zealand, which is something recent, right? So this is just telling us how effective or how this type of work is really important to the surveillance biosecurity guys. So for today, I will have used epidemiological approach, but like I've said that I pretend to be an epidemiologist today. That's why I've added this to the Sero-Virological approach. So these are just the outline of what I'm going to discuss in a couple of 20 minutes or so. So the first is the introduction. So infectious bursal disease, which is also known as the Bursal disease. This was first discovered in the US in the 1960s in a town called Bursal. That's why it is called Bursal disease. So the disease is highly contagious in chicks within 3 weeks of old chicken. So and in terms of the serotypes, there are two serotypes. We have the serotype 1 and the serotype 2. So for the serotype 1 is only in chicken, while the serotype 2 is found both in chicken and what in turkey. So, but in terms of the mortality rate, the IBD1 is the one that is of a concern to the world. And for the serotype 1, we have 3 antigenic groups. The first one is the classic one. We have the variant and the very virulent. So the only difference between these 3 antigenic subgroup is just about the mortality rate. So for example, in the case of the classic one, it's just between 25 to 50% of mortality, while the case of the variant antigenic is just less than 10%, but the very virulent one could be up to 100%. Okay, so that is why we need to understand the dynamics of how this disease transmits within poultry. In terms of the clinical signs, so this is just a few lists of clinical signs that we have. Because you can have the subclinical and the clinical one. The subclinical doesn't really have much effect. Like you might not be able to see the physical effect of the subclinical one. But in terms of the clinical sign, these are some of them, like the aneurysm, like the depression. If you look at this gentle chick sitting over there, this chicken is what is depressed and it's also having what a ruffled feather. So if you see something of this sign, that shows that this chicken is not looking fine. Something is wrong. So, but there are other clinical signs that we can find. So in 2017, the World Health Organization made IBD to be what like a disease of concern. And in 1993, there was a case in New Zealand, South Down in Otago, but luckily the outbreak was eradicated. And a case also occurred in 2019, and it was also eradicated. But since then, the biosecurity guys in New Zealand, what they do is they carry out testing every year just to see if there is possibility of an outbreak at some point. So this is always done with the poultry in New Zealand or the egg-laying industry. So looking at this world map here, this is just to show where IBD, which is the infectious viral disease, is present in the world. As at the time where I got this map, we don't know what has happened in between yesterday and this morning. So for example, you can see this is the reason why I've shown New Zealand. It shows that New Zealand is the only country in the world that is free of this disease. That's the reason why the biosecurity guys are trying as much as possible to know what sort of things they can do or how can they detect if there's an outbreak in the poultry industry. So I see you can see Australia here, they've got this variant and the classical one, but luckily for New Zealand, it's still looking good. We hope it stays that way. Okay, so For the epidemiologists, what they do is they use the diagnostic methods in order to test those chicken. Like after they slaughter them, then they try to select few samples, test these samples, and see if there is a positive case or a negative case. So if there is a positive case, then that calls for a concern that there might be an outbreak in the poultry. So, but for this analysis, for this work, what I've considered is the broilers industry, because you can have the egg-laying one and you can have the broiler one. So for the broiler farm, what they do is they have a day-old chicken. After they've been hatched, they move them to the farm. Then they stay in the farm for 540 days. After that, they slaughter them. So what the biosecurity guys at MPI does is that they just pick 10 samples from the lot, do the testing, and see what sort of analysis they come back with. So if it is negative, good. If there's a positive case, then they have to do further analysis. So in their approach, there are a couple of different diagnostic methods, but in New Zealand, they use the serological approach and the virological approach. In terms of the serology, what they do is the serological analysis is just to check the antibodies in the chicken, while the virology is if you are able to isolate the disease in your sample. So these are just the two different things. Two different ways whereby you can check